Welcome to another fascinating episode of Omni, where we explore the hidden secrets of nature and advanced human technology. Today, we focus our lenses on a tiny aquatic marvel that walks gracefully across the surface of a quiet pond. Meet the incredible water strider, an insect that defies gravity and uses the water surface as its personal sensory canvas. Have you ever wondered how these creatures navigate the vast aquatic landscape without ever sinking beneath the dark, cold depths? While surface tension keeps them afloat, their true superpower lies in an extraordinary ability to read invisible ripples around them. To a water strider, the pond is not just a habitat, but a highly sensitive biological radar screen transmitting data. Every single movement on the water creates a unique vibration that travels outward like invisible acoustic waves across the surface. These tiny ripples carry vital information about the surrounding environment, alerting the insect to potential danger or a hidden meal. Imagine being able to see the world, not with your eyes, but by feeling the subtle vibrations beneath your feet. This remarkable insect possesses specialized sensory receptors located on its long legs, perfectly designed to intercept these faint surface vibrations. When a struggling mosquito falls into the water, it generates a very specific frequency that ripples outward in all directions. The water strider instantly detects this unique frequency, turning its body toward the source with absolute precision and deadly speed. It does not need to see the trapped insect, because the ripples provide an exact mathematical coordinate for the strike. But the pond is rarely completely silent, and the wind constantly creates random waves that could easily confuse ordinary predators. How does this tiny hunter distinguish between the meaningless background noise of the wind and the desperate struggle of prey? The secret lies in its advanced biological filtering system, allowing it to ignore low-frequency waves generated by the breeze. It only reacts to the high-frequency, erratic vibrations that signify a living creature thrashing against the tight surface tension. This flawless ability to filter out environmental noise makes the water strider an absolute master of aquatic vibration sensing technology. Scientists have spent decades studying this fascinating mechanism, hoping to unlock the secrets behind such a perfect natural detection system. By observing these insects, researchers discovered principles that are now revolutionizing how humans approach security and environmental monitoring systems globally. In the realm of modern human engineering, we call this fascinating concept seismic imaging, or advanced vibration sensing technology today. Just like the water strider relies on surface waves, our security systems depend on subtle vibrations traveling through the earth. We bury highly sensitive geophones deep underground to monitor vast borders and protect critical industrial facilities from any unauthorized intrusions. These buried sensors act exactly like the microscopic sensory hairs on the delicate legs of our incredible aquatic insect friend. When a heavy vehicle drives near a protected border, it sends powerful low-frequency seismic waves rolling through the dirt. Conversely, human footsteps generate a completely different rhythmic pattern that the underground sensors immediately pick up and analyze for threats. The ultimate challenge for human engineers is exactly the same problem faced by the water strider in a windy pond. How do we teach our computers to separate genuine security threats from the harmless vibrations caused by passing wild animals? If our sensors trigger an alarm every time a deer walks by, the entire security network becomes completely useless quickly. Therefore, scientists have developed complex mathematical algorithms, inspired directly by the sophisticated neural processing found inside the tiny water strider. These artificial intelligence algorithms constantly analyze the incoming seismic data, looking for specific acoustic signatures that match known human activities. Just as the insect ignores the wind, our modern security networks learn to completely ignore the rumble of distant thunderstorms. This incredible synergy between biology and engineering demonstrates the immense value of studying even the smallest creatures on our planet. Let us take a closer look at the microscopic anatomy of the water strider to understand its magical sensing capabilities. The legs of this insect are covered in thousands of microscopic hairs that trap tiny air bubbles against the water. These trapped air bubbles not only provide vital buoyancy, but also act as physical amplifiers for the incoming surface vibrations. When a ripple hits the leg, the air bubble compresses slightly, sending a mechanical signal directly to the nervous system. The insect processes these mechanical signals in milliseconds, allowing for an almost instantaneous reaction to any nearby movement or disturbance. It is a biological masterpiece of design, optimized over millions of years of evolution to ensure survival in harsh environments. Human engineers marvel at this efficiency, striving to replicate such rapid signal processing in our own advanced early warning systems. Imagine a vast network of underground sensors protecting a national border, working together like the 6 legs of the insect. Each sensor detects a fragment of the vibration, and the central computer combines them to pinpoint the exact intrusion location. This method of triangulation is precisely how the water strider calculates the exact distance and angle of its struggling prey. By measuring the minute time difference between a ripple hitting its front leg versus its back leg, it knows everything. It knows the direction, the distance, and even the approximate size of the creature that created the disturbance in water. In military applications, acoustic triangulation uses the exact same geometric principles to locate the origin of distant enemy artillery fire. It is truly mind-blowing to realize that our most advanced tactical technologies share a foundation with a simple bug. Nature is the ultimate research and development laboratory, conducting endless experiments to find the most efficient solutions to complex problems. The water strider teaches us that sometimes the most valuable information is hidden within the subtle background noise of life. We just need to develop the right tools and the proper mindset to listen carefully to what the environment says. Let us return to the quiet pond and observe a real-life hunting sequence orchestrated by this brilliant aquatic predator. A small moth flutters too close to the surface, its delicate wings brushing against the water and breaking the tension. The moth panics, flapping wildly and sending a chaotic symphony of high-frequency ripples racing across the otherwise smooth pond. Several meters away, the water strider stands perfectly still, its sensitive legs resting gently on the elastic surface of water. The first wave hits its front right leg, triggering a rapid cascade of neural impulses straight to its tiny brain. In less than a blink of an eye, the insect processes the frequency and confirms that a meal is waiting. With powerful strokes of its middle legs, it propels itself forward, gliding effortlessly over the water like a miniature speedboat. It adjusts its trajectory mid-glide, constantly reading the fresh ripples to correct its course toward the frantically struggling moth. The strike is swift and merciless, a perfect demonstration of nature using physics and vibration to secure its next meal. This extraordinary display of predatory efficiency relies entirely on the successful interpretation of invisible kinetic energy traveling through a medium. Now, let us shift our perspective back to the human world, where invisible kinetic energy protects our most valuable assets. Deep beneath the perimeter fence of a massive industrial facility, a network of fiber optic cables lies buried in dirt. These cables utilize distributed acoustic sensing, turning miles of ordinary fiber into a continuous, highly sensitive underground microphone, recording everything. When a person walks above the buried cable, the pressure creates microbends in the fiber, altering the internal light transmission. The system detects these microscopic changes in light, translating them into a digital signature of the footsteps occurring above ground. Just like the water strider filtering out the wind, the security software must filter out the vibrations of nearby highways. Heavy trucks rumbling down the road generate massive low-frequency waves that could easily blind the entire delicate security system. But advanced machine learning models have been trained to recognize and eliminate this background noise, isolating only the suspicious activities. The software can even distinguish between a human climbing a fence and a stray dog digging a hole nearby today. This level of precision is absolutely critical for preventing false alarms and ensuring that security personnel respond only to threats. We are essentially building artificial water striders on a massive scale, using silicon and glass instead of biology and chitin. The parallel between the natural world and our technological advancements is a beautiful reminder of our deep connection to nature. Every time we face a complex engineering challenge, there is a strong chance that evolution has already solved it perfectly. Biomimicry is the practice of learning from and mimicking these natural strategies to invent more sustainable and effective human technologies. By studying the water strider, we are not just learning about an insect. We are uncovering the fundamental laws of physics. We are learning how energy propagates through different mediums and how to extract meaningful data from a chaotic, noisy environment. This knowledge extends far beyond border security, impacting fields like earthquake detection and structural health monitoring for our large bridges. Seismologists use massive arrays of vibration sensors to listen to the deep tectonic whispers of the Earth shifting beneath us. By analyzing these deep terrestrial ripples, they can predict volcanic eruptions and provide crucial early warnings for devastating, massive earthquakes. The planet itself is like a giant pond, constantly vibrating with energy that we are only just beginning to understand. Imagine a future where every building and bridge is equipped with a nervous system modeled after our tiny aquatic friend. These smart structures would constantly monitor their own structural integrity by listening to the internal vibrations caused by daily stress. If a microscopic crack begins to form inside a concrete pillar, it would emit a very specific high-frequency acoustic signal. The embedded sensors would instantly detect this anomaly, warning engineers long before a catastrophic failure could ever endanger human lives. This proactive approach to maintenance and safety is entirely inspired by the biological sensitivity of creatures living in our ponds. As we push the boundaries of technology, we must continue to look closely at the natural world for profound inspiration. The water strider may be small and seemingly insignificant, but its mastery of vibration sensing is a true biological marvel. It reminds us that sophistication does not always require massive computing power or incredibly complex machinery to be highly effective. Sometimes, elegant simplicity and perfectly tuned sensory organs are all that is needed to conquer a challenging and dynamic environment. The next time you walk past a quiet body of water, take a moment to look closely at the surface. Watch the water striders dance across the invisible tension, knowing that they are actually reading a complex web of information. They are living sensors, perfectly adapted to their unique world, teaching us invaluable lessons about perception and advanced signal processing. From the peaceful tranquility of a forest pond to the highly secured perimeters of our most sensitive modern industrial facilities, the principles of vibration sensing connect these two vastly different worlds in a beautiful and unexpected symphony of applied physics. We are slowly learning to see the universe not just with our eyes, but by feeling the subtle rhythms everywhere. Our journey into the microscopic and the magnificent continues to reveal how deeply interconnected all forms of life truly are. OmniEyes is dedicated to bringing you these incredible stories, bridging the gap between natural wonders and cutting-edge technology. We hope this exploration of the water strider has changed the way you perceive the hidden forces shaping our reality. The subtle ripples on a pond carry secrets that have the power to protect nations and save countless human lives. It is a testament to the endless ingenuity of evolution and the boundless curiosity of the human mind seeking knowledge. Thank you for joining us on this fascinating deep dive into the world of biological sensors and modern seismic imaging. If you enjoyed learning about how insects inspire our security networks, please consider sharing this video with your curious friends. Your support allows us to keep exploring the amazing intersections of nature and science that make our universe so captivating. Stay tuned for our next episode, where we will uncover yet another brilliant secret hidden right in front of us. Until then, keep observing the world closely. Stay endlessly curious. And thank you for watching this episode of OmniEyes.